Hello grade 10. Today you will take the atomic physics, the nuclear atom. Atom. What is the meaning of atom? Atom is the smallest building unit of all matter. Okay? Atom consists of or made up of nucleus and particles as the neutrons, protons and electrons. Protons and neutrons is found inside the nucleus. Okay? Protons carry a positive charge and neutrons are zero charge or neutral charge, and the electrons, which carry a negative charge, orbits around the nucleus. Orbits around the nucleus. Protons and neutrons are known as nucleons. Discovery of the nucleus. Thomson's Plum Pudding model. Okay? At first, we have to know that all the neutral atoms have an equal amount of positive charge as the negative charge. This is the Thomson's Plum Pudding model. He suggested that the negative electrons were embedded inside a pole or a sphere which carry a positive charge. Thomson's model of the atom. Let us think about the plum pudding model of the atom, okay? Who can tell me what are the plums and what is the pudding? What are the plums and what is the pudding? The plums here are the negative charge, the electrons. And what about the pudding? The pudding is the positive charge.
In this video, we're going to focus on Rutherford's gold foil experiment. Now, in this experiment, he wanted to test the Plum Pudding model to see if it was accurate, if it was a good representation of the atom. And in order to carry out this test, he needed a source of alpha particles. And so he used a radioactive element such as radium, which naturally decays and emits alpha particles. So he enclosed it in a container with a tiny opening, and thus he got a beam of alpha particles coming out through it. Now, an alpha particle is the same as a helium nucleus. It's basically a helium particle with a 2+ charge. It consists of 2 protons and 2 neutrons. So that's an alpha particle. Now, what he did with these alpha particles is that he beamed it on a gold foil. Now, this gold foil was surrounded by a detector, which looks something like this. My drawing's not perfect, but you get the picture. Now, this particular detector was coated with a fluorescent substance, so when the alpha particles were to hit it, it would flash. Now, what he realized is that many of the alpha particles went straight through the gold foil. However, some of them bounced back, while others were deflected at large angles. And so he came up with some very important conclusions based on what he saw. And he realized that the Plum Pudding model couldn't be correct. Now let's talk about some of those conclusions. Imagine if this circle represents an individual atom. The fact that most of the alpha particles went straight through the gold foil, what conclusion do you think Ernest Rutherford came up with? Since most particles went through the atom, or the atoms of the gold foil, he concluded that the atom must be mostly empty space. Now, there was something else that he came up with. The fact that some of the alpha particles bounced back, he realized that there must be a very dense center, which we know to be the nucleus. The second thing that he realized is that some of the alpha particles, they were deflected at large angles. Now remember, the alpha particle consists of 2 protons, 2 neutrons. So the alpha particle has a +2 charge. Now we know that opposite charges attract. If you have a proton next to, let's say, an electron, these two, they're going to feel a force of attraction. But like charges, they repel each other. So if you have, let's say, 2 protons next to each other, they will feel a force of repulsion. And so they're going to move apart. Now the fact that some of these alpha particles were deflected away from the nucleus indicated that they must have the same charge as the alpha particle. So he concluded that at the center, you have a region of dense positive charge. And so these conclusions were pretty much accurate for the atom. The atom is mostly empty space, and we do have a nucleus that contains positive charge. Now, this experiment doesn't identify the presence of neutrons, but it does tell us that the nucleus is positively charged due to the protons that are in it. And so those are the things that Ernest Rutherford came up with through this experiment. So to review, he discovered that the atom is mostly empty space due to the fact that many of the alpha particles went straight through the gold foil experiment. But the fact that many of them were deflected at large angles showed that there had to be a very dense center with positive charge known as the nucleus today. So that's a summary of Rutherford's gold foil experiment. So that's basically it for this video. And for those of you who like it, feel free to subscribe to this channel for more educational content. So thanks again for watching.
All the neutral atoms consists of nucleus, which carry the neutrons and the protons inside it, and the electrons which orbit around the nucleus. All the electrons carry negative charge, and the neutrons are zero charge or neutral charge, and the protons are positive charge. Atomic structure. Any atom consists of nucleus, contain proton, positive charge, and neutrons with zero charge. And around the nucleus surrounding it, the electrons are located in the energy levels. Okay? What about the charge of proton, neutron, and electron and its mass? Proton's charge is positive 1.6 multiplied by 10 power negative 19, the same for the electrons but with negative charge, negative 1.6 multiplied by 10 power negative 19, and for the neutron is zero charge. What about the mass of proton? The mass of the proton and the neutron is the same, 1.67 multiplied by 10 power negative 27, so its relative mass is 1 to 1. What about the electron's mass? Is 9.11 multiplied by 10 power negative 31. It is very light, so its relative mass, it will be 1.1 over 1836, approximately 2000. We can write the symbol of the element as X, okay? There are here two numbers, one at the top and the other at the bottom. A at the top, it is the mass number or the nucleons number, which is the sum of protons plus neutrons, okay? And the Z, it is the atomic number or the proton number. We can determine N, which is the neutrons number, by subtract A minus Z, the mass number minus the atomic number. How can we determine here for the three examples the number of proton, the number of nucleon, and the number of neutron? The first one, this is a sodium atom, okay? It has two numbers. The first one, it is 11, which is the smallest number, and the second one, it is 22.9, it is the largest one. The smallest, it is the proton number, or the number of electron. What about the 22.9? It is the nucleon number, okay? It is a nucleon number. How can we get the number of neutron here? By subtract 22.9 minus 11, it will be 11.9. What about the second one? Magnesium 12, 24.3. 12, it is the proton number or the number of electron because it is the smallest number. And the largest one, it is the nucleon number, which is the sum of proton plus number of neutron, okay? How can we get the neutron number? By subtract 24.3 minus 12, it will be 12.3. What about the third one? It is the chlorine. Chlorine 17, 35.4. 17, the smallest one, it is the proton number or the number of electron because it is a neutral atom. All the neutral atom, the number of proton equal the number of electron. They are the same. What about 35.4? It is the nucleon number, okay? It is the sum of proton plus number of neutron. How can we get the neutron here? By subtract 35.4 minus 17, it will be 18.4. This is another example for the chlorine, okay? Chlorine here 1735. The largest one, it is the mass number or the nucleon number, okay? What about the smallest one? It is the proton number or the atomic number. What is the number of proton? It is the atomic number. It is 17. What about the number of electron? The same as the proton number because it is neutral atom. It will be 17, okay? What about the neutron? The neutron here, we have to subtract 35 minus 17 to get it. 35 minus 17, it is 18. The isotopes. What is the meaning of isotopes? Isotopes are the same element, have the same number of protons, but different in number of nucleon. 1, 2, 3. For example, here, the hydrogen isotopes. Hydrogen has 3 isotopes, okay? H11, H12, and H13 have the same number of proton, 1, 1, 1, and different in the nucleon number, 1, 2, 3. And here, the number of neutrons are different. 1 minus 1 equals 0, 2 minus 1 equals 1, and 3 minus 1, it will be 2 neutron. What about the uranium? Uranium has 2 isotopes. The first one, 235, and the second one, uranium 238. Here, the number of neutrons are different. The first one, it is 143. 235 minus 92, it will be 143, and the second 238 minus 92, it will be 146. Another example for isotopes, carbon. Carbon has 3 isotopes, carbon 612, carbon 613, and carbon 614. This is carbon 12, carbon 13, and carbon 14. Have the same number of protons, 6, 6, 6, but different in the nucleon number, 12, 13, and 14, and different in the neutron number, 6 neutron, 7, and 8. Your homework, inshallah, it will be the questions in the course book from 22.1 till 22.11, pages 311, 313, and 314. Thanks.